In this video, I'm going to go over the tangent ratio. Okay, so this is something we've already discussed with the CLT before these notes. All right, but we're just going to focus on just the trig ratio tangent. So I'll draw a right triangle. All right, so there's my right angle. All right, and the way this works is I'll just use this as my theta. All right, and so for the tangent of theta, that ratio is going to be the opposite side over the adjacent side. All right, so this is the opposite side from that theta, and this is the adjacent side. All right, so you'll notice that the hypotenuse, which is here, is not going to be a part of this trig ratio. Okay, now again, if you change to this angle over here, then that would adjust what is the opposite side and what is the adjacent side. So just be careful and always focus on, okay, what angle is the perspective that I'm looking at it from, and that will help you decide how to write the ratio. Okay, let's do these first four. Okay, so it says the tangent of theta. Tangent of theta is over here. So if that is my angle I'm looking at, for opposite over adjacent, the opposite side of theta is 10, and the adjacent side is 8. So reducing that is going to give me 5/4. If I switch to look at alpha, the tangent of alpha will be the opposite side, which is now 8, and the adjacent side for alpha is 10. So that reduces to 4/5. Okay, looking at this next one here, I'm going to go back to theta. So the tangent of theta is going to be the opposite side of 5 over the adjacent side of the square root of 3. All right, now if you wanted to rationalize the denominator, you could multiply by the square root of 3 over the square root of 3 to get 5 times the square root of 3 over 3. But I just want you to know that this and this are the same thing. Okay, the tangent of alpha, if I move to this one here, that's going to be the opposite side, which is the square root of 3 over the adjacent side, which is 5. All right, so that's just kind of the basic setup for tangent. Okay, I'm going to skip these, but check out the key so you can see the difference between those. Now, let's bring in the calculator just for a little bit here. All right, the key thing when you watch these videos, I'm going to be using the Desmos app on my iPad, but whatever calculator you have, make sure you're in the correct mode. All right, all of these are degrees. So when I go to Desmos, I always click the wrench to make sure that I'm in degrees. Okay, so this first one I'll do is number 9, which is the tangent of 31 degrees. So the tangent of 31 degrees, which it looks like it wants me to round to the nearest hundredth. So the nearest hundredth is going to look at the thousands place, of 10 hundredths. So the nearest hundredth, that 0 is going to round the 0 to 0. So it's going to be 0.60 here. 0.60 approximately. I'll do the tangent of 25 degrees now. I know I'm skipping a bunch. So the tangent of 25 degrees. All right, here we go. This one will actually do something. The thousandths place is the 6, and the second 6, I should say. And that's going to move the first 6 up to a 7, so 0.47 approximately. All right, and then check out the key for the remaining of these. Just get used to the calculator so you know to check the mode and then how to type the stuff in. Okay, now those two that I just did were if you knew the angle, you could find the trig ratio tangent of that angle. So these next couple I'm going to do is when you go backwards. So let's say I have a triangle, a right triangle. All right, and here's my theta. All right, and let's say that I know that the opposite side is 3 and the adjacent side is 4. So I could write the tangent of theta equals the opposite side of 3 over 4. So we can actually go into the calculator. Since we know the trig ratio, we can say, okay, calculator, I know the ratio for tangent of this angle. Can you tell me what angle it has to be so if I took the tangent of it, I would get 3/4? So you can. You just have to use the inverse tangent function, which is tangent to the negative first power of 3/4. All right, so when you type this in, you're essentially saying, okay, here's the trig ratio for tangent of this angle. You tell me the angle that would make this true. Okay, so I'm going to type in. So all you do is go to the function thing and it's tangent to the negative first power of 0.75, which is 3/4. So that would be approximately 30, if I round to the nearest degree, 37 degrees, right? So this theta is approximately 37 degrees. That would make that true. Okay, so let's go ahead and type in a couple here. Tangent to the negative first power of 11.43. Tangent to the negative first power of 11.43. So if the ratio is 11.43, the angle that would make this true, if I took the tangent of it, would be approximately 85 degrees. Well, it says the nearest 100. Let's take a look. Okay, so that 9, okay, so it's going to be 85.00. Okay, and then here we go. Let's do, what did I say, 24, so 1.425. So tangent to the negative first power of 1.425. So nearest 100, so look at the thousands place the 0, rounds that 4 to still be 4. So 54.94 degrees approximately. I'll put my degrees for. Okay, so that is it for if you know the trig ratio and you want to ask, okay, what angle does it need to be? So if I took the tangent of it, I would get that trig ratio. Okay, let's do a couple more. All right, and this will be using some solving after you set up these trig ratios. Okay, so it says to find the measure of the angles. So I'm going to start with theta. All right, when I look at theta, I know the tangent of theta is equal to the opposite side over the adjacent side. So that means the tangent of theta is equal to 11 over 9. Okay, now again, I don't know theta, so I'm going to type into my calculator tangent to the negative first power of 11 over 9. So let's type that in. Tangent to the negative first power of 11/9, which is going to be approximately 50.71 degrees. Let's see what it says. To the nearest 10th. Change it up on me. Nearest 10th will be 50.7 degrees. So theta is approximately 50.7 degrees. All right, so now if we want to find alpha, using that same process, remember again, it's still tangent is always opposite over adjacent, but depending on what angle you're looking at, it changes which sides are your opposite and what sides are your adjacent. So for alpha, the opposite side is 9, and the adjacent side is 11. So now to find alpha, that's going to be equal to tangent to the negative first power of 9 over 11. So if I type that in, tangent to the negative first power of 9 over 11, I'll get a different angle. In this case, I'll get approximately 39.3. So theta equals 39.3 degrees. Now, I'm hoping you see that if you were to look at your theta here, which is 50.7, and your alpha, which is 39.3, if we were to add those together, we would get approximately 90 degrees. Remember, this is a right triangle, so alpha and theta have to be complementary, right? They have to add to be 90 degrees. Okay, let's try 28. We're going to do two more, 28 and 30, then I'm all done. All right, 28, find the measure of the missing leg. So we have this side here. They're giving us 37 degrees. So this is the opposite side from that angle, and this is the adjacent. So I'm going to write tangent of 37 degrees equals opposite, is my unknown, over adjacent. All right, now, to go ahead and move this 11 over, I'm going to multiply both sides by 11. So my answer is going to be 11 times the tangent of 37 degrees. All right, I'm going to round to the nearest 10th. So 11 times the tangent of 37 degrees. To the nearest 10th is going to be approximately 8.3 units. So 8.3 units. All right, so that is how we use the trig ratio tangent to find that missing side. Okay, so now this next one is very similar. There's no triangle, all right? But I wanted to show you this one because I'm actually going to rewrite it, but putting this tangent over 1 to create a proportion. So then I'm going to do cross products, which would be x times the tangent of 15 degrees equals 25 times 1, which is just 25. Now I want to get x by itself, so I'm going to divide both sides by the tangent of 15 degrees. So my exact answer is x equals 25 over the tangent of 15 degrees. My approximate answer, I'm going to use the calculator to round to the nearest tenth, to do 25 over the tangent of 15 degrees, which is going to be approximately, to the nearest tenth, 93.3. So 93.3 units. All right, approximately. All right, so anyway, that is, let me make sure I did that right. Yes, I did. That is how we use tangent. There's obviously a lot of problems that I skipped, so please check the key for that. Check on the, try the homework, check the key for that as well. If you have any questions, come see us for office hours. Good luck.